finally, the third type of asymptote is an oblique or a slant asymptote. This happens when the degree of the numerator is 1 more than the degree of the denominator. So this is degree 2, this is degree 1. 2 is 1 more than 1, right? So if this is 1 more than this one, you have a slant or an oblique asymptote. And you find that asymptote by doing long division. So let's have a look at this example. It says to find all the asymptotes. Well, the vertical asymptote is where the denominator is 0. So x minus 1 equals 0. Add 1. X equals 1 is your vertical asymptote. The next part is to find the horizontal asymptote. Well, to find a horizontal asymptote, we have these two cases, where the degrees of the numerator and denominator are the same, or where the degree of the numerator is less than the degree of the denominator. This is 2, this is 1, degree 2, degree 1. So we don't have a horizontal asymptote. However, this degree is 1 more than this degree, which means we have an oblique or a slant asymptote. And to find it, we need to do long division. So we could do x minus 1 divided into all this, or since this coefficient is 1, we could do synthetic division. Remember, we do this to find out what to put on the outside. We put 3, negative 2, 1 on the inside. Bring this down, multiply, add, multiply, add. So this is your remainder. The last number is always the remainder. We also know we decrease this by 1, so this is just our x, and that's our constant. So if you were to write this in quotient and remainder form, you would get 3x plus 1 plus 2 over x minus 1, right? That's what we learned in the last section. Well, whenever you're looking for an oblique asymptote, you don't need the remainder part. All you care about is the equation you get from the quotient. It's y equals 3x plus 1. And you can see this is in y equals mx plus b form, right? So you can tell that this is a linear equation. So if you graph this, it will be a straight line, and it's slanted such that the slope is 3. So this is going to be your slant or your oblique asymptote.